Hi everyone. So now in this video, we'll be solving 6.3. So it's the composition of F and F. We want to find the composition of F, and we want to find the set which represents the domain of the composition of F and F. Now, we know that, okay, let's start. We know that f of x is equals to x plus 1 over x. This is what we're given. Now, if the composition of f and f can be written as f and f of x. So meaning that from here, you can see that our inner function is f of x and our outer function is f of x. So we're then going to substitute f of x where we see x in f of x. So this will be f of x plus 1 over f of x. Now we know that f of x is actually equals to x plus 1 over x plus 1 over x plus 1 over x. So now let's simplify this. Let's write it the way it is on this side. So this is equals to x plus 1 over x plus 1 over x plus 1 over x. Let's try to simplify this term before we go further. So then this is equals to x plus 1 over x plus 1 over. Now, to simplify this, let's try to change these terms over here. Let both of them be fractions. Now, we notice that x is not a fraction, so let's make it a fraction. In order to make it a fraction, we'll then say x over 1. But 1 over x is already a fraction. Okay, so then let's simplify the term in the denominator. Okay, let's try to simplify it on the side so that then we don't have long steps. So we have x, sorry about that. So we have x over 1 plus 1 over x. So we want the denominators to be the same. So for us to have a same denominator, we'll notice that the LCD here, our LCD will be equals to what? Will just be equals to x. So meaning that we want this over here to be x as well. And here on this second term here, we see it already, the denominator is already x. So for us to have a denominator of x at the fraction where x, we have x over 1, we'll then multiply by x over x. So then we have x over 1 multiplied by x over x plus 1 over x. So this is equals to x squared over 1. X squared over x, because then this will be 1 times x, and that will give us x, and then x times x, that will give us x squared. So then we add this term, so this is plus 1 over x. Now that we can see the denominator the same, so this will then be equals to, let's take the denominator, which is x in this case, and then we can add the numerator. So this is x squared plus 1. Now let's take this and substitute it in this. So then this is equals to x plus 1 over x plus 1 over x squared plus 1 over x. Now we know that if we have 1, sorry about that, if you have 1 over a over b, this becomes b over a. So meaning that this term over here will then change. So this is equals to, so let's say equals to x plus 1 over x plus x over what? X squared plus 1. We are not done. So we want to simplify this expression. So meaning that we want to add all these 3 terms. So the other thing is that we change the terms that are not fractions and make them fractions by dividing by 1. So this will then equals to, this term is not a fraction, let's make it a fraction, we'll divide by 1. So this will be x over 1 plus 1 over x plus x over x squared plus 1. Now, from this expression, you notice that our LCD, lowest common denominator, will be what? Will be x squared plus 1. So meaning that we'll use this LCD such that all the denominators will have all the denominators of the three expressions, 1, 2, 3, should look exactly like the LCD. So how do we do that? So for the first term, we have x over 1, right? We want the denominator to look like the LCD, meaning that we can multiply by what? By x over x squared plus 1 over x times x squared plus 1. Because then this x times x squared plus 1 will multiply with this one, and then we'll have a denominator of x times x squared plus 1. Plus, now, we notice that our second term is actually 1 over x, right? So we have 1 over x. Now, for us to get x times x squared plus 1 in the denominator, it means we have to multiply by only x squared plus 1. So then we say multiply by x squared plus 1 over x squared plus 1. Right? Now, let's go to the last term. The last term says plus x over x squared plus 1. Now, we already have x squared plus 1. We do not have the x, and we want the denominator to have x times x squared plus 1. So meaning here we'll multiply by x over x. So now let's simplify that. So this will be equals to x squared times x squared plus 1 over x times x squared plus 1 plus x squared plus 1 over x times x squared plus 1 plus x squared over x times x squared plus 1. Okay, now that the denominator are the same, you see this part, the denominator is the same as this one, is the same as that denominator. So meaning that we can add the numerators. So let's put the denominator the way it is. So this is equals to, what is our denominator? It's the LCD, x times x squared plus 1. Now let's simplify this. Multiply the x squared inside. So x squared times x squared is x to the power of 4. X squared times 1, that's plus x squared. And here we have plus x squared plus this one over here plus 1. And here we only have what? We only have x squared. All right. So now this is then equals to x to the power of 4 plus 2x squared. Actually 3, because we have 1, 2, 3. We are adding like terms. So this will be 3x squared plus 1 over x to the power of 3. So that is x times x squared, and x times 1. So that is x to the power of 3 times x. Therefore, the composition of f and f is equals to x to the power of 4, x to the power of 4 plus 3x squared plus 1 over x to the power of 3 plus x. Okay, now we have found the composition of f and f. So we have found the composition function that we were asked to find. Now, was that the only thing we were asked? No. We were also asked to find the domain of the composite function that we find. So let's do that. Okay. Let's do some erasing here. Okay. So that we make a space to find the domain of the composite function that we just calculated, because we were also asked to find the domain of the composite function, and not only the composite function, both the domain and the composite function. Okay, now let's find the domain of the composite function. So let's draw a line here. Our composite function was x to the power of 4 plus 3x squared plus 1 over x, sorry about that. Okay, let me fix that. Yes, so over x to the power of 3 plus x. Okay, now for us to find the domain of this composite function over here, so this composite function over here, first of all, we have to look at two domains first. We first have to look at the domain of the inner function. Now, we know that this expression can be written like this. Meaning from here, the inner function is what? Is f of x. And we know that our f of x is equals to x plus 1 over x. Meaning that the domain of f of x will be equals to x such that x should not be equals to 0. Right? Now, let's find the domain of the expression of the composite function. So this is the expression of the composite function, right? And we see it's also a fraction, meaning that the domain should not be equals to 0. I mean, everything under the denominator of the composite function should not be equals to 0. So we find the expression, the domain of the expression, meaning that we find the domain of this expression over here that we have calculated, because we want to find the domain of the composite function, meaning that we find the domain of the expression. So this is the expression. Now from here, you'll notice that the denominator is equals to x to the power of 3 plus x. So for this composite function to be defined, for this expression to be defined, let's not call it a composite function at the moment, but let's say for this expression to be defined, we want the denominator to not be equal to 0. So this means that x will be an element of real number such that x to the power of 3 plus x should not be equals to what? Should not be equals to 0. So basically, that's where we are. So now, one can then say, okay, fine. We are not yet done. We also want to find the domain of, what's this? Okay, so we found the domain. Okay, let's simplify this before we actually continue. So then this will be equals to x is an element of real number such that x, okay, let's take out, let's say x squared in this case. No, it's x. Then that will be x squared plus 1 should not be equals to this. So meaning that in this case, right, x should not be equals to 0. Because then if x is equals to 0, this expression over here will be what? Will be 0, meaning that this expression over here will also be 0, and therefore the expression will not be defined. Now, to find the domain of the composite function, the domain of the composite function, it is actually the intersection of the domain of the inner function as well as the domain of the expression. So meaning that this will be x is an element of real number such that x is not equals to 0. And that's then how we find, or rather how we solve 6.3. Sharp.